Hi, I'm Sean O'Kane with ChipEstimate.com, where we bring you the latest trends and information in IP and semiconductor design in the EDA industry. I'm at the TSMC OIP Ecosystem Forum, and we're going to talk to many of our partners today who have collaborated with TSMC on ultra-low power IoT platforms and subsystems. Let's go. Hi, I'm Sean O'Kane with ChipEstimate.com. With me today is Gilles Depeyrot, CEO of Dolphin Integration. Thank you very much for joining us today.
Thank you for inviting me.
Well, actually, I said I was going to do this later, but I got to get it right out of the way. You just won the Partner of the Year award for specific to a ULP specialty IP.
Right.
Partner of the Year with TSMC. So congratulations. Did you want to talk a little bit about that or that award?
Well, it's the third time we get an award, and it's the second year in a row for the silicon IP, standard cells, and memories that we deliver in the More Than More processes. So it's great recognition for the work we do with TSMC.
Yeah, very good. Congratulations. So IoT applications, especially wearable and battery-powered devices, they face a performance and power challenge. We've been hearing that over and over. And this is driving the need for a new type of low-power processor. And it's kind of fitting that Dolphin Integration is here to present a breakthrough low-power design methodology, enabling optimization for low-power networks in an SoC. That said, what are the benefits to a designer with this new methodology that you've developed, especially with the driving IoT marketplace?
Well, the first benefit is enabling the design of low-power SoCs, because some companies master the low-power design flows, usually large companies with sufficient resources, but a large number of companies and our fabless customers do not. Mm-hmm. So the first thing is enabling that. And the second benefit is reducing the design cycles and accelerating time to market.
Well, the reduction of low-power consumption for an SoC is very important and very complex task. And what you have done is kind of address that. And what are some of the challenges of constructing a low-power SoC?
So that's a good question. I'll try to answer it a little bit bottom up. The first step is the always-on domain. You know, in these battery-powered devices, you may be in sleep mode 90 or 99% of the time, and battery life is critical. And then you need to have triggers, because you're going to want to wake up the SoC. So it can be a real-time clock, or it can be a voice trigger. Mm-hmm. And you have specific speed constraints that you need to meet, because these triggers don't work at the same frequencies. So you need new standard cell libraries to be able to meet those constraints. So you need to optimize the always-on domain. And then you want to build power islands. So the construction of the power islands is a complex task. The traditional approach is building rings or distributing power switches. You have to size them, determine the right number of them. Mm-hmm. Then you go to the back end and you do voltage drop analysis. And if it's not okay, you do an iteration. Okay. So we have a solution with a patented cell that handles the inrush current, so you can remove that iteration and more easily build the power islands and more securely. Mm. And then, so you have the power islands. Okay. So then you need the power management network. Right. So embedded voltage regulators. And that's generally a custom task. I mean, people take an existing voltage regulator, they adapt it, mm-hmm. And then when they do the next SoC, they take that one, then they adapt it. And we've come up with a library approach. So we do that on what we call the Delta standard, with a number of rules that we've defined to be able to quickly and easily assemble a power management network, and to also address the verification challenges. Mm-hmm. So then you have the power management network, and you need to control all that. Yes. You have the power islands, you have the voltage regulators.
Now you need control.
Right, you need some kind of control network. So we have a solution which we're promoting with a methodology and I'd say modules to help assemble easily and hierarchically a power management network for low power SOCs.
Very nice.
And then I'd say once you have all that, the top level SOC integration is a challenge because the designers need to move from an RTL design flow to a CPF, UPF plus RTL design flow. So they need to change the design flows, they need to change their practices, and that's a challenge.
Right. And what you're trying to do is make it a little bit easier.
Right, a little bit easier in
Yes.
each of these issues.
Yes, each of those 4 areas, I
Right.
guess. So, is there any chance that a company like Dolphin may succeed in launching a new standard on its own? So, that's a challenge in itself. So, I mean,
Yeah.
go ahead.
Well, as a mixed signal and low power specialist, we've been entertaining a long-standing relationship with TSMC and some other major foundries. What we're looking at is proposing to the big EDA suppliers our, I'd say, expertise, our know-how in modeling and simulation of power and control networks, so that we can bring easier solutions to our customers, and particularly the second-tier fabless customers.
Good. Very nice. So there is a chance, there is a possibility that can happen
With partners.
with
Right.
partners, and this is what it's all about here, talking about collaboration, and that's that's why TSMC is here every year with the OIP and all of their partners. And
Exactly.
right. So great job, and congratulations on that award. That is so cool. 3rd year.
Right.
All right.
Thank you.
Yeah. So for Gilles, Depeyrot, my name is Sean O'Kane. We'll see you next time on Chip Estimate TV. Thank you so much.
Thank you.
All right, man.